Okay, everyone. I think that everyone already have a take a break, and also there's some drink coffee, right? So we are the next session of our the track one. We are very proud to invite James to share us about the music and Python. Let's welcome James.
Hi guys, how are you guys doing? How's your PyCon going so far? Good? Oh, there's no sound. How's your PyCon going so far? You hear some noise? Alright. I'll try later. Okay. So yeah, my topic today is about creating and analyzing music with Python. And before I start, let me ask a few questions. Who here plays music? Any sort of hand who plays music? And who here considers themselves like a very knowledgeable in Python, like an advanced Python programmer? Alright. So like, if I make any mistakes, please correct me. And so yeah, like my talk today will be just showing you a little bit of tools for you to get started with creating and analyzing music in Python. And yeah, like hopefully by the end of this talk you get inspired, probably try a few things, and yeah, with a few lines of code you'll be able to do some stuff with. And so first and foremost, I want to say a very big thank you for Python ID staff and all the sponsors for making all this event happen. And thank you for Percodis, Rabai, and Benz for supporting this event and hosting it here in this beautiful city. And very big thank you for allowing me to speak at this event. Yeah, a little bit about myself. I used to be a sound engineer and musician. And yeah, I used to be very active, and I went to the NAMM show, which is one of the largest music trade shows under a scholarship. And currently, I'm working as a software engineer at Traveloka. So yeah, when you think about music, I think you usually think about like some actual physical instrument. But when I started learning music, and I think doing some audio recording, doing some recording, I always wondered how does all this data, like all this like acoustic sounds can be transferred into like some digital audio workstation like this. And I think once I started picking up programming about 2 years ago, and I think music was one of the things that drives me when I started learning programming, because there's this few questions that I really want to figure out myself. One of the first things is like, how is music represented? And what can we do with musical data? And how to read and store musical data? And what sort of other interesting questions can we ask? And yeah, why I decided with Python, I think because like when I was looking around, you can either program music with C++ or like Python has a great library for music. So I started with Python because there's a lot of wonderful libraries available. Easy to get started and easy to use. Some of the libraries have really good documentations that you can just play around with. And Python is really good for testing out your ideas and making quick prototype. And yeah, if you're inspired to get started with like something, not just music, I guess. Like how can you get started? First, I think one of my way to do it was just to explore the libraries that are available. Make some projects out of it, and yeah, it helps check out what the other community is doing too. So I think for the rest of my talk today, I'll be talking about these three things, like some of the libraries that I explored and play around with, and some of the projects that I've done, and some of the projects that the community has been doing. And so, first, the libraries. So I think one of the first libraries that I'm going to talk about is called PySynth. PySynth is just a suite of simple music synthesizers written in Python, and it helps you compose music based on note and duration. So, like if you understand basic music, you should be able to just specify the note name and the length of the note, and it provides some helper scripts that turn like ABC notation, which is similar to like a text file containing music data, or MIDI files into a WAV file. And it's provided under the GPL license, the general programming use license, so you can use it and modify it, whatever. And just a little bit of demo for that. So yeah, this is a Python demo that I made for. Is it clear for everyone? So yeah, I think here we'll be exploring like 3 things, like writing a song that can be parsed by the module, and how to generate a WAV file, and how to mix 2 different WAV files from a single WAV file using the utility functions that's provided here. So yeah, first we want to import the module. So I'll show a bunch of things. And yeah, this is a small snippet that I prepared. Maybe anyone who's knowledgeable in music can tell me what this song is. I can just run this, and yeah, we can certainly try and convert it to a WAV file and hear it for ourselves. We'll be writing to a demo song called Wave. Should be done. Now there'll be a demo song file right here. We can hopefully listen together. Oh, the audio is not on. Let me just try it with my mic. Why is this not playing? Very low. Yeah, let me just show it to you here. Hopefully you can hear it. See, that's basically just writing notes. So like when I get started, like I don't know much programming, and I think like having this kind of projects, having this kind of like, oh, you can just put a note name and a note duration, and you can just make music out of like writing something. It's a good way to get started, and that's one of the things I did. So that's a simple song. And another example, this time I have to give my credit to the creator of this package for providing this. And the song looks a little bit longer. And we can just generate the WAV files for both. Alright, it should be done. And what we have should be that's one of it, and the other one is so there's 2 different lines, and you can combine it both together into a single file. Okay. Roughly 30 seconds. Alright, it should be done. Yeah, once you have that, you can have like a polyphonic. Yeah, hopefully that shows a little bit of one of the things that you can do with like this package. It's a very simple package, and I think it's pretty much you play around with it and you can get sounds out of it, which is pretty nice. The second package I want to talk about is one of the things that I was using quite a bit when I was doing my music studies, and I think this package is really good because of the documentation was just wonderful. And this is called Music 21, and Music 21 is a Python-based toolkit for computer-aided musicology. So, like if you're studying like classical music, like traditional notes, this package is really great for mapping all those notes from XML files or like compressing XML files into like the notes objects that this class has. And it helps you with questions about music theory through the use of computers. One of the good things about this is they have a very large data set of music. So if you want to like analyze something, you can just start looking at the corpus and start analyzing it straight away. before like finding some data sets or data sources online. And it allows you to compose music algorithmically or directly as well. It's licensed under LGPL, which is lesser license, or PSD, which is like some of the things, like the data sets, obviously, you can't share it, like it's copyrighted, but I think most of the things you can use it in your work. So like a little bit of demo again. Go to music 21 again. So again, this is a small demo. We'll learn how to parse and analyze some built-in data sets, how to initialize and play around with the node object and the chord object. So hopefully this, like if you look at this lines, it should be pretty simple, it should be pretty understandable, and I hope you want to try it yourself as well. So first, as well, like before we start, we want to import the package first, and one of the built-in, all the tunes are usually in the corpus. So in this case, I want to take corpus, like from the bump piece, WV66.6, and yeah, after importing, we can see the program can directly analyzes the key signature of this, and we can also show it using the XML reader. So it takes a little bit of time, but once you do that, you can show all the musical notes right here. And the next topic I want to talk about is about the node. So to initialize a node object, just like in regular music theory, you have a node name like C, D, E, F, G, A, B, C, and you can initialize it A4, which is on the fourth, something like this, and you can print out some information about it. So you can find out the name, you can check whether it's a node, something that's useful when you're doing a lot more data analytics stuff or something, and like the pitch of it. So here is like we have the object F, which is the node F5, and we can print out its name, its pitch, its node. We can also find out the frequency, which is something that like frequency is another representation of the note. Usually, like when you study music theory, you learn about the C, D, or when you're like learning a little bit about the audio processing and stuff, like how does that translate? Then you want to start thinking about like A translates to 440 hertz, and doubling like the octave means doubling frequency. So we can find out the frequency of F, the pitch class string, and like pitch class. So pitch class string and pitch class is actually just the same, like returns it should return the same thing, but pitch class string just returns you a string instead. It's easier for you to use for your project, right? And here we can see it's not exact, and like only A is an exact, but everything else is based on that because we have like the formula is based on logarithmic scale, and so we have those things. And next, we can also check out its accidentals. We can also transpose, which is something that usually is pretty hard for, like, when you have to, like, if you ask, like, a musician, like, what's A4 transposed by, like, double diminished sticks? You have to count, but yeah, in this case, you can quickly find out what note is this. It's actually F double flat, which is it should be an E flat. And yeah, we can also analyze this chord. To say chord, you can introduce like a list of all the notes in the name. We can find out some things about it. Sorry if I'm going a little bit faster. We can add a note to an existing chord. So like we want to add a B flat 4 in this case. And yeah, to show a flat here, you use the dash instead of flat because it's confusing for the program. And so it's based on documentations, that's how you do it. And yeah, you can see that you have added the chord, and you can see how the chord looks like in musical notations. And the one last thing I want to show you is like a feature called chordify. So from the earlier example, we have this. We can just quickly chordify it and show it. So what chordify does is basically have 4 different lines: soprano, alto, tenor, bass. You can combine it into like one single line, of course. Pretty quickly. Like this seems really good, but like, I think one of the hard things is like you have your data sets must be either like XML or MIDI format, which is something that you have to work, like process your data beforehand. So okay, another package is called Librosa. So far we've been talking about like the easier part of music analysis, music creation, on whether you, like if you understand basic music, you know the note and you know the number, like you know the duration, you can be able to do it. The Librosa is more difficult because it's more like mathematical. You have to use, like you have to understand a little bit on like transform, constantly transform, and yeah, it basically works on wave files. And you know, this package is great for music information retrieval system, and yeah, a great tool for audio processing, dynamic time warping, and such. So I'm gonna quickly go to the demo. So yeah, the demo is how to get MIDI events from a wave file, an actual wave file, how to convert MIDI events into timestamps, and like how to obtain a chromogram. So let me show you the data sets I'm using. I think this is one of my original compositions, but like just to show. So that's like a small demo of the actual song that we'll be analyzing. So and yeah, as usual, we want to import. This is the file name that we have. It's loaded, and when we load it, it returns 2 arguments. One of them is y, which is the waveform that we are going to analyze, and sampling rate. So I can probably go into a little bit more detail on sampling rate, but like I'm running quite a lot of time, so I'm gonna go ahead and just let's run the default beat tracker, and let's copy this code actually. So once we run that, we have beats times CSV. So it records like it outputs all the beat times that it's providing. This is all the beat times, and yeah, one of the more interesting things you can do is to be able to see a chromogram, which is the information about the pitch classes. And I'm just gonna, like I'm gonna share this code online too, so hopefully if I'm going too fast, you guys can check it out on my GitHub. And yeah, one of the things I'm gonna do is plot the original chroma and the initial chromogram. To run again. So this is what chromogram looks like, and yeah, if you listen to the music earlier, like it has some of the like from like Librosa has a very built-in tools to be able to process like the precision, like the underlying chords is just and yeah, you can see the length of each note, like G, F, E, D flat. F can be easily seen there. But yeah, like I think yeah, one of the all of those data can be used with the right approach to recreate the original song. And but like depending on the song, like if you have like a song with like a lot more drums, you have to do some more things to do it. Like one of the things that I was doing was just to oversample the frequency axis so that you can reduce the sensitivity of the tuning deviations. So let's just run this and see this. You can see like you can help clear things out and make it more accurate, the representation to be more accurate in this case by like oversampling a little bit like the frequency buckets. And so, yeah, more information you can find on the actual website. And yeah, there's a website called PyCon Music, which lists all the libraries that you can play around with and like, explore your projects. And so I'm gonna talk a little bit about like some of the projects that I made myself and like try to play around. And I think everything for me in projects is like usually you start with a question, and like by the end of the project you want to find out something about it. And so I think one of the first things was like a very simple project that I made. It's called Tune Finder, and basically what if I can ask the computer to find out what is the key signature of the song. Like for me, like finding a key signature has been pretty easy. I'm fortunate to have a relatively perfect pitch, and so listening to like a key signature was easier. But I think for some people, like understanding the key signature, so what the bass key is, one of the harder things. Like I think I was trying to come up like how do I usually process it, and basically the way I do it, that I can think of and I can probably code it, is something like this. So yeah, you usually have this note name starting from C, all the 12 keys in a musical scale, C all the way to B. Is this big enough for everyone? Okay. And so basically in the diatonic major scale, like C, D, E, F, G, those without the sharps, I want to label it to be 1, 0, 1, 0. And basically, yeah, I'm writing some comments. You want to parse the MIDI, and you reduce each note to like its base key. So like for like C, if it's C5, like when you get the MIDI file, it'll give you a written value of 60. You want to make it 0 to be like the actual C value. And yeah, this is, you can probably check this code out when I put it on GitHub. But the basic concept here is just to create a circular matrix based on this, based on the diatonic system, and you multiply it with the count of each note in the melody. And so by doing that, you find out which one has the most number of notes. And most likely, like based on the diatonic scales, you multiply the matrix there, so you figure out which key has the most number of notes in it, and that should be the key. And yeah, I can show you the short demo. So this is fine. Sound like E. Something like this. It'll be, and this is a very basic approach. As you can see, like the number of line of codes is just like 50 line of codes. But what I want to show you is just based on this. I think PyCon makes it very easy to get you started. Like I think my idea was just to multiply matrix together. And I was using NumPy. I was using a circular package from SciPy to be able to create circular matrix quickly. And MedBomb to parse the MIDI data. And let's go to the next slide. Like another project that I was doing, pretty much I was just playing around yesterday when I was thinking about what can I show you guys today for the talk. And like basically this is chord detection. And yeah, this is far from perfect. I was just playing around with it yesterday. And yeah, how do you read information from a media stream and translate it to something useful? And so it's not a simple project. It's like I can probably still make some tweaks on it and uses the Music 21 library that we showed you guys earlier. A little bit of demo for production. So in this project, basically, like what I want to do is just like I have a musical MIDI here, and I want to read some chords out of it. Like basically, it's a very simple chorus, which is a triad. So you can, take the MIDI input. So like, let's say I want to press this. I've made the triad. here I'm playing C major, here I'm playing C minor, here I'm playing D flat. So like basically how you read from a string input and convert it to an actual chord. And the code is actually the code is actually pretty simple too. I just wrote the string value, so like converting MIDI information to a string value that you can parse by Music21, and you process tryouts, and basically just collecting it into a set and process it. And yeah, this is just you're entering a main loop, which is processing all the MIDI data and process it the way it is. And yeah, 60 lines of code, and you can get something started out of it. And yeah, I hope. Let's continue first. So yeah, this another project of mine is called Networks and Music. So I think I was learning a little bit on like network analysis that time, and yeah, I was using the data MIDI of the song September from Earth, Wind and Fire, which consists of 15 different tracks. And yeah, what my project basically do is to create a representation of the note and note movement and graphics, when the notes are the vertices and note movements are the directed edges. And I was using like driven algorithms, I think, which is an algorithm that forms clusters based on edges that are most likely to be connected. So I used R for this project, but it's actually very old in PyCon. Like the graph package that I used was also available in PyCon, which is called like iGraph. And like MIDI parsing, you can easily do the MIDI parsing as I was doing earlier. And the other part that I have to do, like, you can use pandas for the data frame processing. And I think for the operations as well, you can use pandas for it. So yeah, here are like one of the like graphs that I created. Like this was more like a network analysis project and also a physical different project. I can talk about one of them. So you can see this is a network for the main melody. I think the network reveals the main melody movement. And like one of the interesting things, I don't know, pointer or something. You can see there's a single note, like F sharp right there, or at the other end, like G. And that basically is a passing note. So, like passing, if you're familiar with the song, like some of the notes that you just go up and down, and basically just like take moves. So I'm currently running out of time, I think, and I have to go a little bit faster. So this is one of the graphs I created based on all the 15 different tracks. And the 15, like basically you can see separate of notes, the common notes between all the different instrumentations, how spread out the notes are. So the first one, the red one is piano, the blue one is actually the bass, and you can see that some of the chords they have a very small range of notes. And this is another project. Like I'll probably just say like this is one project I actually worked on with like a few friends, and I was working on the JavaScript physical algorithm for it. After I was doing the pure data and like a bunch of my friends doing. You can check it out here. I hope to make this available as well. And yeah, there are some few projects that I find it very interesting currently. Like RT mono audio to MIDI was just like currently like listening to audio and converting it to MIDI is a very tough problem. Like current access installation yields results about 70%. And basically what like Anna did, it was to try to like parse monophonic audio. So she was playing a recorder and like making a small range of frequency that you can analyze before actually basically a subset of this problem. She's trying to solve the subset of this problem, and it works really well actually for that kind of thing. And like one of the most interesting projects I think you should definitely check it out is called AI Duet. It's a project by Yotam Man, which I admire a lot. And it's basically you can play around with a MIDI keyboard or a keyboard, and you play something and it will respond to you with something else. And so things I learned. I think PyCon is a really wonderful tool to test out your ideas and just build something out of it. It is still my go-to programming language for quickly test out my ideas, prototype something, like just making simple projects like yesterday, for example. And PyCon has really great libraries for you to get started. Making projects are one of the best ways for you to learn about technologies. For me, I think learning like NumPy, SciPy, and doing those projects is really fun. And yeah, we're fortunate to have a lot of PyCon enthusiasts here in Indonesia, so you have a good community to learn from. And yeah, like some words of advice, just find something you're passionate about. Find a question that you want to figure out, do your best to solve the problem, collaborate, and never stop learning. And I think, yeah, feel free to hit me up or find me after this talk if you have any questions. And yeah, thank you so much for being a great attendant, a great audience.